Hello, my dear students. I welcome you all to the next subtopic of oscillation chapter. In this subtopic, we are going to understand the magnet vibrating in a uniform magnetic field. So, what will be the question we can form using this subtopic? So, the question it can be like this: there are an expression for time period for a magnet vibrating in a uniform magnetic field. Also, we have to prove that the magnet performs angular SHM. So we'll start our explanation to the magnet vibrating in the uniform magnetic field. There's an explanation, this will be the diagram. So magnetic field, it is upward. So this is the uniform magnetic field because it is of equal length line and they are equally spaced. I can say this is a uniform magnetic field. Okay, here we are having the magnet which will always be parallel like this. Its initial position is always parallel. So if suppose the magnet is parallel to the magnetic field, there won't will be any restoring force or torque acting. So purposely we will tilt this magnet by some angle theta. I will tilt this magnet by some angle theta. So such that this is the force which is acting here. So this force it will be moving this magnet in this direction. Because of the restoring force it will move in this direction. Again this magnet it will come to this position. Again the force acting will move in this direction. Again the force acting will move in this direction. So this magnet it is going to perform angular SHM by moving here to here, again here to here like this. So magnet will be moving in the angular SHM manner. So we have to prove this theoretically. How this we can derive that it is moving in the angular SHM format. So if the bar magnet it is freely suspended in the plane of a uniform magnetic field, it remains in equilibrium with its axis parallel to the direction of the field. If it is given a small angular displacement theta about an axis passing through its center, perpendicular to itself and to the field and release, it will perform the angular oscillation. So just the explanation given to you now, it is performing angular SHM. Okay, so this is again performing the angular SHM. So we will be deriving the formula for time period now. So let nu be the magnetic dipole moment and B be the magnetic field. In the deflected position, the restoring torque acts on the magnet that tends to bring it back to its equilibrium position. So what is the magnitude of this restoring torque? The magnitude of the restoring torque, the magnitude of the restoring torque, it is actually given by tau it is equal to mb sin theta or mu b sin theta. So here the mu represents the magnetic dipole moment. In some books it is also written as capital M. So note that capital M and mu both are the notations for magnetic dipole moment. Okay. So tau it is equal to mb sin theta. So if theta is very small, if theta is very small, I can say sin theta it is nearly equal to theta. Sin theta it is nearly equal to theta. Therefore tau it is equal to mu b. Tau it is equal to mu b into theta. Tau it is equal to mu b into theta. Okay. So, but as per the property of SHM, this tau and theta they are actually in the opposite direction. Suppose I consider the axis like this, the magnet is like this. So here the theta is in this direction. This is the direction of theta, but the force it is in opposite direction. The torque acting it is in opposite direction. So since in vibrating magnet under uniform electric field under uniform sorry, magnetic field, I can say tau, torque and displacement are in opposite direction. Torque and angular displacement are in opposite direction. Are in opposite direction. So therefore, what is the value of torque? Therefore, tau it is equal to minus of mu b theta. It is minus of mu b theta. Okay, but as per the concept of rotational dynamics, but for body performing rotational motion, so the magnet it is rotating, right? A part of rotational motion is happening. For body performing rotational motion, what tau it is equal to? Tau it is equal to I into alpha. Tau it is equal to I into alpha. So therefore, I can say I alpha it is I alpha it is equal to minus of mu b theta, right? So therefore, what is the value of alpha? Alpha value will be equal to minus of mu b theta divided by I. So here, since mu b and I are constant, since mu b I are constant, so I can say therefore alpha it is directly proportional to minus of theta. So this is the property of angular SHL. This is the property of angular SHL. So therefore I can say therefore the magnet vibrating in uniform magnetic field it performs angular SHL. So since the slides are over, I request you to pause the video. You have to write these things. I'm erasing some part from here. I will erase the part here. So since this is the property of angular system, so I can say therefore um, the magnet performs angular SHL. So it was the question that prove that it is performing the angular SHM or not. So we have proved therefore magnet performs angular SHM because this is the property of angular SHM. Alpha is directly proportional to minus of theta. Now in angular SHM, since we know it is performing angular SHM, so in angular SHM, what t value it is equal to? Angular SHM, the time period it is equal to 2 pi under root of alpha divided by theta. 2 pi under root of alpha divided by theta. So here, if you suppose neglect the negative sign, what you will get? Since alpha it is equal to mb theta divided by I, we consider magnitude. We are not interested in direction. So therefore, what is alpha divided by theta? It is equal to mb, or I can say mu. So mu b divided by I. So this equals 2 pi divided by under root of alpha divided by theta will be mu b divided by I. So I can say therefore, what is the formula of t? T it is equal to 2 pi under root of I divided by mu b. 2 pi under root of I divided by mu b. So this is the formula of t. Okay. So this is the formula of time period of vibrating magnet, right? So I request you all to please pause the video. You have to write these things. So this completes our subtopic magnet vibrating in the uniform magnetic field. The next topic that we are going to learn is the MCQs from the textbook. Thank you so much all of you for your kind attention. Goodbye, take care, bye bye.